Lovely. So we're being recorded now. This is Frank Coe, and this is a quick tutorial on the TINA, Texas Instruments Electronic Circuits Simulator. The software, once we open, will display in this fashion, and we can very quickly build components by clicking and dragging different devices onto our desktop. So I'm going to click and drag a resistor and click that in place there. Click and drag another resistor, put that there. And let's do one more for giggles and laughs and put that one there. Let's get a voltage source, put that one there. Let's bring in a ground and put that one there. Now for R3, now let me change this up a little bit. Let's bring all of these guys a little bit more over this way. That's good. And let's zoom in a little bit on this so you can see things a little better. Can I go to 200? Yeah, I can go to 200. Okay, hopefully you can see this pretty well. If I click on R3 and I do Control R, Control R will rotate this. There's one way to rotate. Another way to rotate is after you select an item, such as this, any item that you select will turn red. So if I wanted to rotate this particular fellow, I believe I can rotate this way, and rotate this one back, and rotate this way, and this way, and this way. And we're all back here. So depending upon the type of circuit that you're looking on building, we have the ability to make some devices appear vertically and some devices appear horizontally. So what I'm going to build here is 3 resistors. I'm going to change the value of the resistors. R1 is shown as 1 kilo ohm. R2 will be changed. If I double click this guy, I have a dialog box, and I'm going to make this a 2.5 with a lowercase k, hit enter. Now it's a 2.5 kilo ohm. R3, I'm going to change this to a 3.7 with a lowercase k, and there we go. The voltage source starts off as 5 volts, and I'm going to make this 4.5 and hit enter, since most of our battery power packs are 3 AA cells, giving us a total of 4.5 volts. Now, the connecting wires are very simple. Each one of these components has a little red X at the end of their devices. So if I point to the little red X, my pointer changes from an arrowhead to a pencil. And if I click and drag there and connect, oh, now I have a connection. And if I go to click and drag to here, now I have a connection. If I go to click and drag right to here, I have a connection. And let's see, I want to do something also. Insert. Okay, I think this is enough. So why don't I go ahead and click and drag to here? Okay, we have a nice connection. Whoops. If there's something I don't want, I can select it and hit delete, and the delete goes away. I can select a wire and move the wire down like so. So I have a little better proportionality. Then grab this ground and click, and now I have a connection there. So to make sure I have good electrical connection, I can select this component, pull this up, and you see the wire goes up with it, which means, yes, it did make not just a visual connection, but an electronic connection. So let me bring this guy back down. Now grab this guy and pull this up, and see nothing detached. The wires moved up with it, so I can bring this back down. So that's a happy camper. Select this guy, pull outwards, and the schematic moves along with it, move it up, and the wires move along with it. So that means I have a very, very good electrical connection. So that's how quickly we can build components. Now with 4.5 volts, 1K, 2.5K, I have 3.5 plus 3.7. So that gives me roughly what, 7.2 kilo ohms. And if you do your math very quickly, 4.5 volts, 4.5, and turn the calculator on, All right, turn calculator on first. So 4.5 volts and divide by a total of, let's do, where's my, don't borrow somebody else's calculator. It really messes things up. So 4.5 volts and divide by, what do we have, 7.2 k ohms. So that should give me about 6.25. Oops, let's hit engineering. Where's my engineering key? Again, don't borrow somebody else's calculator. Okay, so I have, looks like 625 microamps. That's good. And then that should be my total current. And if I wanted to get a rough approximation of my voltage drops, I simply do voltage divider. So we decided that the total of these was going to be, what, 7.2 k ohms. So I'm going to take 1 divided by 7.2, 1 divided by 7.2, multiply by the 4.5. And I'm predicting we should have somewhere in the neighborhood of 625 millivolts across the first resistor, and times 2.5, so somewhere around 1.56 volts around the second resistor. So that's pretty good approximation for now. I'm going to bring in right here this, I believe if you hover, that should be, it's a voltage source. Select that and delete. No, what I want is meters. So select meters. We were on the basic tab. We also have switches, meters, sources, semiconductors. So we want to go to meters. And in meters, I happen to have the very first one here. This one should be my voltmeter. So I'm going to place a voltmeter number 1 here, and I'm going to orient this particular guy so that I have the plus side of the voltmeter facing the plus side of the source. I'm going to connect this right there and connect this guy right there. Okay, and I'm going to bring another voltmeter, and the system will automatically identify, I'm going to rotate this. The system will automatically identify the second voltmeter as voltmeter number 2. Take and connect here, and take and connect here. And see if this wire is okay. All right, it is connected. It's not just a visual thing. All right, and now connect this guy over to here and connect this guy over to here. All right, so we said that we should have roughly 625 millivolts here and roughly 1.56 volts over here with about 625 milliamps of current flowing. So let's see if I take this guy, I haven't played with this, but let's just flip this guy horizontally and see if I can put that in. No, I don't think that was a good connection. So what I need to do is delete this wire and make a connection from here to there, and make a connection from here to here. Okay, and now if I go to move this, yes, my amp meter and wires move accordingly. All right, let's see how we do. Let's go ahead and do analysis. And under analysis, we want DC analysis, and we want a table of DC results. Boom. And here's our table of DC results. Check this out. Didn't I say that the current should be about 625 microamps, and it shows the current through each one of these devices is 625 microamps. Didn't we also say that the voltage across R1 625 millivolts. There's my 625 millivolts. I said that the voltage across R2, 1.5625, and it rounds off to 1.56, which is lovely. So all of our information is intact. This is great. Let's see how much information to get. Oh my goodness, look at all this information here. This is terrific. So I'm going to widen this guy a little bit. And oops, I don't mean to shrink this. I'm going to move this guy. Tell you what, we're going to move this guy over to here, move this guy over to here. Okay, pretty good so far. And I'm going to insert a title block. And the title block, no, that's not what I wanted to do. That's an import file. I wanted to insert text. That's the easiest thing to do. All right, and the insert text should be circuit design by somebody we know. And let's date this today is 3-20-20. And let's see, this will be a series 3R circuit design. And I'm going to go to font tool. And the font tool, I'm going to have something nice and big, and something, say, about this size would be terrific. And then hit OK. And then hit the check mark. Boop. Oh, look at that. I misspelled it. What a doofus. Okay, let's go ahead and fix this. Series. Okay, now hit the check mark. Yay, all right. And it appears I've lost my analysis box, but that's okay. That's easy to bring back, like so, like so. Here's my analysis box, and let's fill this in. Look at that, look at that. And so now, once everything is done, we should be able to do a nice snip of this. Let me grab this guy here. Okay, yeah, it's under analysis, so I won't be able to do anything other than put my probe onto the circuit, which I'll discuss another time. Fantastic. So I will engage my snip tool and snip. And this will be my snip tool right here. I will hit new, and it grays everything out. So I will go ahead and select just this part of it that's relevant. Select, and then hit edit, copy. And now it's copied onto the clipboard. And then I'm going to engage Microsoft Word. Here's Microsoft Word. Widen this guy, and then hit Control V for paste. And guess what? I've got a really, really nice document here that shows a screenshot of my schematic, the changed values as I've demonstrated, the 3 voltmeters as I've inserted, ground, the amp meter in place, and then all the values, and then the title block, the text box as shown. And on the Word document, hit File and Save As, and put it under some class. And we will call this Series 3R by someone, and save it. Boom. Now it's saved, and now it is, as you can see with the title up here, this can now be imported into Canvas. So that's how easy it is to use Tina from Texas Instruments. Thank you all so very much. And I will go ahead and stop the recording.